What's up, fellow programmers? This is Alex Louie. Today we're going to cover the for loop. This is our third installment of our loop extravaganza. Started with the do while, then the while, and this is now going to be the for loop. The first thing I want you to notice is that how we construct a for loop. So the for loop is going to have the keyword called for, and you're going to have parentheses, an open parentheses and a closed parentheses, and then I'm going to explain what's in between. So what are the three elements that we need to have in a for loop? The three elements is, first, you need a counter variable that needs to be initialized. So in this first column, you can declare a variable that will be in this for loop scope, meaning that if you do this declaration here, it will not be accessible outside of this for loop. The other thing you need to do is have a breakout statement. So this can be known as expression 2. When this expression is false, it will break out of this loop. If it's true, then it will execute the body of the loop. And the body could be denoted by this compound statement over here. Within a for loop, you can have any type of C++ statements. You can have a while, you can have a do while, you can even have another for loop, and you can also have in statements, out statements, you name it, you could have it. Okay, there is no limitation to anything within a for loop. Just remember that anything in this for loop could potentially be repeated multiple times depending on your expression. So again, first statement on the first column is your initialization. So this initialization will be used and will only be executed once. The next column is your expression. This will control how many times we're going to go into the body of the loop. And last but not least is your actual increment or decrement of your loop control. So we use this control variable so that once we get to the comparison in the expression, it will be able to break out or stay within it. And I'll show you how it behaves. So in this particular example, we are going to initialize count equal to 0. So the first step that's going to happen is count is going to be declared, and you're initializing the value to 0. Okay. The next step is we're going to do and evaluate this expression here. And we're going to compare, is count less than or equal to last? Yes, it is, because count right now is 0 and last is 5. So is 5 less than or equal, it means 0 less than or equal to 5? Yes, it is. If this is true, then we will execute the body. So what we have here is we're going to print out the value of count, which is 0. Once we're finished executing everything in the body, this will go back and execute the increment expression. Okay, so this will get executed and it will increment the count by 1. Once it increments the count by 1, we go back to our expression comparison, or logical or relational expression, or it's more like a Boolean expression, and we do another comparison. Now count has been incremented by 1, so now it's going to be 1 less than or equal to last. Is 1 less than or equal to last? And in this particular case, yes, it is. Because it is less than or equal to last, we will print out the value of count again. So on the first iteration, it was 0. On the second iteration, it's 1. We do all the statements within the compound statement in the for loop body. Okay, we just imagine that there are more statements here. And it will break and come back into this expression 3, which is the third column. So after each pass of the body, it will always come back up to the third expression here. It will increment this by 1, and it will do the comparison. So if you're looking for an order of operations, you can kind of decipher it as follows. So the first step that will always happen is evaluate expression 1. Okay, and we can call this expression 1, expression 2, and expression 3. So actually we can do this. Expression 3. After that, it will evaluate expression, spelling it wrong, expression 2. Okay. Then after that, if expression 2 is true, then execute the body. Okay. If false, break out the loop. Execute the body, go to 4. Okay. So we execute the body, then evaluate expression 3. Then 5, go back to step 3. Okay. So this 3, 4, 5 here is repetitive by nature. This will be the what happens in the first 2 steps, but then 3, 4, 5 will continuously repeat until we break out of the loop. So let's actually do that. So let me just do that. If we start out again, we evaluate expression 1, right? So expression 1 is going to be count equals 0. Then we evaluate expression 2. Expression 2 is comparing count less than or equal to last, which is 0 less than or equal to 5. Step 3 says if expression 2 is true, execute the body and then go to 4. So in this particular case, it is true. So we'll execute the body, and now what's going to happen, how we evaluate what happens next? Well, then it's going to say evaluate expression 3. This will increment count by 1, and now we go back to step 3, sorry, here, and we go back to evaluating this again. Okay, so these 3 steps here, or these 3 expressions here, will go back and forth. So once this is true, then it will execute the body again, and then go back to this expression 3. Expression 3 gets evaluated, and then we go back to the comparison. Okay, remember, this is a pretest loop. This is a pretest loop. So if it's a pretest loop, it means that we're always going to do the expression evaluation here before we even execute the body. Okay, before we even execute the body. Expression 3 is usually going to be a counter variable that will be used in the expression in the expression 2 to decide whether or not we stay in the loop or we can get booted out. Okay, we can get booted out. So this, you can consider this as an exit condition, and this condition will always be either true or false. Okay, will always be either true or false, and this expression will most likely almost all the time be your control variable, where you're either going to increment or decrement, because this will be used in your breakout condition. Okay, this is called a breakout condition. We call it a breakout condition. Okay, so now if we run this, you're going to see that it's going to go from 0 up to 5. Okay, so if I compile and run, there you see it's going to just print out the value of count. So 0, 1, 2, 3, 4, 5. Once it's 5, right, and you print out 5, then it'll go back and 5 will now become 6. Is 6 less than or equal to 5? No, it's not, so it's going to break out of the loop. Now remember, this variable here that we've declared is only, his scope is within this for loop. Okay, it's within this for loop. So outside of this for loop, count is no longer recognized. So if I try and see out count here, it's not going to work. Okay, so I try to compile that. It's going to say that that is not a valid syntax. So as you see here, I've tried to compile this. Count does not exist in the main scope. It only exists within the for loop scope. Okay, so whatever I declare here is only within the scope here. And even variables that are declared within the for loop, which you should never do, will only be within the for loop scope. Okay, only be within the for loop scope. So you have to be careful with your declarations. Okay, so the next example I want to show you is another type of loop, being condition, which in this particular example, what we're going to do is we're going to find out the square and cube of the numbers from 1 to up to last, which in this particular case I've initialized to 3. So what we're going to have is 1 take the square root and the cubed root of each number. Okay, so in this example I'm actually beginning with 1. In your initialization variable, you can start with whatever value that you want. In the first example, we started at 0. In this example, we start at 1. You can start at 5, you can start at 9. It doesn't really matter. It all depends on what the problem is asking for. Okay? Same thing here. We're going to have a condition that will go from 1 to 3 inclusive, because I want to include 3. Okay, I want to include 3. So it's going to start at 1 and then go up to 3. And obviously we'll have our control variable increase so that we can eventually break out of this expression. So on the first pass, this will be 1, and then it'll do a comparison. Is 1 less than or equal to last, which is 3? Yes, it is. Okay, so on the first pass, notice how I don't go immediately to expression 3. I first go and execute this body. Once I execute the body, then it will go into expression 3 now. And expression 3 will increment this by 1. So count will now be 1. So count will now be 2 because it started at 1. So and then it'll go back to expression 2 and say, is count less than or equal to 3? Yes, it is. We go back and execute the body. And then we go back to expression 3 to increment count. Count will now be 3. Is 3 less than or equal to last, which is 3? Yes, it is. So we print this whole body, we execute this whole body, go back, we increment count by 1 again. Count is now 4. Is 4 less than or equal to last, which is 3? No, it's not. So the body will never execute and we break out of the loop. So if we compile and run, there you have it. So what I've done is I've calculated the square and the cube, okay? And for each row, for each count, I'm just gonna do count, then the square, and then the cube on each line, as you see here. Okay, so 2 times 2 is 4, and then the cube of the 2 would be 8, because 2 times 2 times 2 is 8. Same thing here, 3 times 3 times 3 is 27, and the square of that number is 9. Okay, so it's a bit difficult in the beginning when you're trying to trace through a for loop. Just remember that this initialization step only executes once, and this condition on the first pass will execute and decide if you're going to execute the body or not. Okay, once you get past that first pass, then you could ignore this statement here, the first expression, and you'll have to bounce back between this one and this one, where after each execution of the body, you will always go back to expression 3, execute expression 3, and then do the comparison to see if you're going to break out. Okay, to see if you're going to break out. So it's really all depends on these two lines here. Okay, it all depends on these two expressions here. And once you execute the body, remember, you execute the body, You don't go to the expression in comparison. You go back and go to your increment expression, and then you go to your Boolean expression here. Okay, so this most of the time is going to be an increment expression or a decrement expression. It could be, you don't have to necessarily increment count by 1. You can also do count by 2. So I can also do this. Count is equal to count plus 2. So if I want to increment by 2, then I can do that. Okay, I can assign count equal to count plus 2. I can even do count plus 5. It all depends on what you need. But as long as you have this control variable here, then this control variable should be used in your Boolean expression, because that will decide if we're actually going to stay within the loop or we're going to break out up to the last variable, up to the last actual range or value of that last variable. Okay. It is a bit difficult to understand and grasp, but you just have to start with the ordering first. So I would start with a simple loop. Remember that your initialization comes in first, then your comparison, and then the body. And then after the first pass of the body, then you go back to your incrementer, decrementer, which is known as expression 3. And once you execute expression 3, you go back to expression 2, and it begins again. So you do the comparison. If it's true, then execute that. Okay, so these two guys here are always going to dance with each other, where this expression 3 will get executed first after the pass of the body, and then go back and give control to the middle guy. Okay, so it'll be body, right, middle, body, right, middle, body, right, middle. Okay, you always have to remember that. After the first pass, body, then evaluate the right, and then the middle. And then based on that, if it's true, then body again, then right, then middle. Body, right, middle, until this expression will be false. If it is false, then you just break out and go into the next statement after the for loop. Okay. Thanks for listening. I hope you learned something. You're gonna have to do some practice on it. I will put up some practice videos so that you can practice on your for loop, while loops, and do while loops. If you have any questions, you can always look for material at www.parttimeadjunct.com, or you can email me directly at parttimeadjunct@gmail.com. Thanks for listening. Happy programming.